So thanks very much. Actually, that's my first time at the SF video meetup, and I'm glad to have a talk. And I will be talking about the web-based adaptive VR and 360-degree streaming. I'm Reinhard Grandl from Bitmovin. I guess you all know Bitmovin, so we provide video streaming solutions where you can deploy your fancy services on top of that. And I started as a player developer at Bitmovin in 2013, right after it was founded. And now I'm working more or less as a solution architect, parts in Europe, Austria, and parts here in the Bay Area. So in mid-2015, also Bitmovin entered the VR and 360-degree space, which was pretty awesome. And we thought, why not go for a player? But first of all, I have to disappoint all those of you who think VR is a pretty new topic. But what we see here is some crazy machine, which was really called Headset, from Martin Healing in 1962. And it gives you the experience of riding a motorcycle in the street of Brooklyn. So you really can feel the wind in your face. You can feel the vibration from the motorcycle seat. You can see the 360-degree view, and you can even smell the city. So that's pretty awesome. But I guess there was no YC around this time, so there was no funding for this fancy company. And yeah, somehow they lost the interest, so we are not seeing those types of things today. Anyway, things like VR and 360-degree videos has come to the market in recent times and also in the past, but why do we think that it will succeed now? So what we think or what we see is that the big players are really pushing their 360 and VR technology, and devices like the Samsung Gear VR, which we have here, are getting really cheap, and I can imagine someone sitting in their living room with the Gear VR, but with this little feature it would have been a little bit difficult. So however, for VR and 360-degree video streaming, we're more or less facing the same several issues or problems which we see in online video streaming. And they are especially true for VR and 360-degree video as the content gets bigger, so we have 4K, 8K frame, and even higher bit rates. So what I'm especially talking about is startup delay, which shows that after 5 seconds, more than 20% of your users already left, and after 10 seconds of startup delay, more than half of your audience is gone. And the majority will, of course, never come back. So users are less tolerant to startup delay for short videos compared to longer ones. So if you go for an advertising video, if you go for some fancy promotion video, things like that, users won't wait 10 seconds actually. And users with a better internet connection, and they know they have a better internet connection, are also less patient for the startup delay. And they will, of course, blame their media provider for that. So that's a very serious problem we have to face. Another one, and I think we all know that too well, is buffering. So users get less tolerant to buffering as well, where in 2011, 1% of buffering decreased the viewing time by 3 minutes. In 2014, 1% of buffering decreased the viewing time by 14 minutes. And that trend is definitely ongoing. Also from the Ericsson Research Institute, we have a pretty funny fact that streaming with a startup delay of 2 seconds and some random buffering for 4 seconds increases your stress level by 40%. So this is more or less comparable to watching a horror movie. And to be honest, in my nightmares, I see a lot of stores and buffering, but that's maybe a whole different story. Yes. So the third and last thing I want to talk about problems is low quality. And viewers nowadays expect a TV-like experience. So if we talk about TV-like experience, we mean probably 720p or even 1080p. And that's also what they expect for VR and 360-degree video. And that's very crucial. And people start leaving your video streaming service, and they will highly likely change your service if you do deliver in bad quality. So what can be the solution to those problems I just described briefly? Maybe adaptive bitrate streaming. I think so, but the success especially depends on the implementation and not on the streaming technology. So just using MPEG- and HLS is definitely not enough. I mean, the standard promises video streaming with lower startup delay and no buffering in the best possible quality. But that, of course, highly depends on the implementation. So I can easily build up a video player which is totally conform to the MPEG- or HLS standard, which has 2 minutes of startup delay, shows to the worst quality, and stores every time. So we really have to go for a good solution on the player side, and we really have to put a lot of efforts in there. But coming back to adaptive VR and 360-degree streaming, I think that's a perfect fit because, as said earlier, the problems for VR and 360-degree streams, like buffering, low quality, and the high startup delay, are even higher with those kind of streaming because of the higher resolutions and the higher bitrate. Just think of a 4K VR or 360-degree frame, which is more or less 10 Mbits, 20 Mbits. So we really have to deal with a lot of bandwidth. And how we at Bitmovin solved this problem was by building up a very efficient MSE-based HTML5 player. So let me briefly talk about the media source extension. The media source extension was specified by W3C, and it allows JavaScript to send byte streams to media codecs with web browsers that support the HTML5 video. And among others, this application allows you to implement client-side prefetching and some buffering of segments for streaming media entirely in JavaScript. So simply said, what you can do, you can build up an adaptive streaming player. And that's exactly what we did. And that's exactly what I want to showcase here. So excuse me, so NAB show was not too good for me. They are always tuning their AC to, I don't know, much too cold. However, as you probably can't see, but I can see it, we have the HTML5 video element here as a core component. As you see, there is no source for the video element, as the media source buffer will take the place of the URL for the source of this element. And in the next step, sorry, it's already a little bit tiny. Anyway, in the next step, we try to get the content. So we try to fetch a video for playback and store it in an array buffer. We can use several different kinds of content. So if we are going for an MP4 container, self-initialized segments, or also init segments and media segments. It's also possible to use separate audio and video tracks. In our case, as you can see here, we're going for an entire MP4 segment, which is just called track money. And we are using a standard HTML HTTP request and just give it a callback function where we can later on use it. So the next step, what we are doing is to specify a MIME type encoding. I mean, this is usually part of the manifest parsing, or you can directly parse it from the container. However, in this little example, I already know what the video codec is, so I'll take the easy way and just specify it here. And the next thing what we do is that we create the media source object itself. And we created it in a way that we first check if it's supported by the browser and if the MIME type encoding is supported. And as you can see here, for the video source, now we create a virtual URL using the create object URL. And later on, we will assign it to the video element with the media source object as a source, as we can see here. And then the only thing we have to do is to wait for an event which tells us that the media source object is open and ready for some buffer to be appended. So no outcome on the right side so far. And the next step is creating our video. So what we do is we create source buffer using the add source buffer with the MIME type and the codec of the video, which we defined already, and get the video segment and add it to the source buffer with the append buffer functionality. In case of initialization and media segments, we just would have to add both. So once the media is pushed to the media source buffer, we get an event as well and can call the play method of the video element and signal the end of stream. And that's more or less it. So are we done? I mean, we are nearly done. So what's missing for an HTML5-based adaptive streamer player is downloading and parsing the manifest, buffer management, adaptation logic, DRM, advertising, skinning, subtitles, closed captions, and a lot of other things which are quite fun to implement. So, but we are talking about VR and 360 degrees today. So we have an adaptive streaming player. So how can we make it VR or playable with 360-degree content? And this is where fancy functionalities with HTML5, JavaScript, and WebGL come into the game. So what we have so far, we see an equirectangular video as source, and we see the entire 360-degree sphere in a flat plane. So that's what we can play so far, and yeah, that's fine. That's adaptive streaming. But now we look for a way to find using standardized web tools like HTML5, JavaScript, and WebGL to render this kind of video in an immersive experience. And what we found in our evaluation and our research was a quite handy project called EliVR. They provide some different projections of equirectangular video to meet the requirements for both desktop, mobile, and VR headsets. And that's what we used. And how do they do that? So they get the decoded video from the video element itself. Then they use WebGL shaders and mathematical transformation to render the new version of the video to a canvas element. And that's more or less it. Sounds easy, but the guys from EliVR did a great job, and they describe themselves as mathematical artists. So you can guess it's not that easy. Anyway, here we see the outcome. In this situation, we have the stereoscopic rendering, and we see that we have the equirectangular video still in place, but we also added the stereoscopic view of the video, and so the 2-eye view shown below. And the only thing what's left now is that we just move it on top of our video player, and we create an immersive VR experience for VR headsets like the Gear VR. And you can already give that a try. So if you have an Android smartphone, I say Android because on iOS you won't be that happy, but that's something I will discuss later on. And we can also have a look. So what we see here is the entire 360-degree video in the flat plane view. And we can simply switch to 2D, which is the projection for desktop, mobile, and yeah, we can navigate around here using the mouse. We can navigate around here using keyboard controls. And if you're on your mobile device, you can even navigate around with some inbuilt sensors. And talking about VR headsets, we just switch here the view. Yeah, that might be a strange use case. And we have the stereoscopic view here, which provides us the correct rendering from the GVR. So I'm happy if you want to give it a try later on, please get it from here and just give it a try. So that's not it. Besides rendering, we also have to do something around that in the user interface. So I already talked about the different views for the different devices. We have to provide a view for mobile, we have to provide a view for desktop, and also different interaction possibilities like the mouse and keyboard, like inbuilt sensors, or even head tracking. We see here the head tracking device of the Oculus, which can be connected to your computer and also be used for the interaction with the video itself. Also, auto-rotation might be of interest, and some of our customers are coming up with strange ideas as well. So what do we see as use cases actually? So of course we have the online video portals like Netflix, and they are also going into the VR domain and into 360-degree video. But we have something like crime scene reconstruction, virtual workspaces, manufacturing and construction, education. And another point I mentioned here is the immersive festival experience. And I want to go in that a little, because we are currently doing a project called Immersive Coverage of Spatial Outspread Live Events, short ICOSOLE. I'm glad there is a short name. Yeah, it was designed by the EU, so says everything. Sorry, it's on camera. So ICOSOLE aims to develop a platform that enables user experience for live events, such as festival, parades, marathons, bike races, whatever, in a very immersive way by combining the high quality content from professional cameras and user-generated content. And our focus is mainly on 360-degree video streaming. So just imagine if you are willing to go on a music festival on the weekend, but then there is some cool deadline for a project coming in and you can't go there, but all your friends are attending, and yeah, what a pity. But with ICOSOLE, you now have the possibility to experience the live event from home. So a lot of people are on events with very high quality recording devices like handhelds, cameras, things like that. And what we did was to combine all the content and synchronize it with the professional cameras and provide the user an immersive experience. So one of our camera arrays was like that. It was standing right in front of the stage in there. Again, the entire view. And if we change it to do the, yeah. It's pretty cool if you watch it with the VR device, then it really feels like you were there. And it gives a good experience if you are not able to attend a festival or whatever event, if you can watch such a stream afterwards. So it looks like we already solved the problem, but it's actually not true. No, we're selling it better. So anyway, what about the device inhomogeneity? And remember I told you that you only can watch it with Android. So on iOS there is this native full screen, which we cannot overlay. So there is no problem. There is no possibility to get a canvas on top of it. Actually, there is a funny workaround available in the community. They just use the video element and they do not play it. They go by frame seeking, and it gives the experience as the stream is playing, but of course no audio. But I guess they will synchronize the audio somehow, and then they will fake the video. However, I don't think that's the way to go. Anyway, we have to find another solution for that. Maybe a native application will fit. Another thing which is critical is the content protection. So using DRM on VR and 360-degree content. So DRM ensures more or less that the decoded frames cannot be extracted. But that's exactly what we do when we do the rendering and we go for the canvas element. So that cannot apply in a DRM case. And yeah, up to now there is no solution on that, to the best of my knowledge. But we are happy to provide here some approaches and also approach some browser vendors. So I think that's something which will be a hot topic in the future. And bandwidth efficiency. So up to now, I guess you noticed we are always downloading the entire video as it is. But the viewport is actually a very small fraction of it. So I would consider this as a waste of bandwidth. Anyway, before I talk about bandwidth and how we can come up with solutions which might fix this problem, I want to talk about audio. So immersive audio is something which is really needed. And you have the 360-degree or VR video experience, which is pretty cool, but you're still going for stereo audio. I think that's not the way to go, and that's not what the user wants. So what we see here is some kind of recording device for binaural audio. So for stereo listening over headphones, you get a quite flat impression from the sound coming from somehow inside the head. But in real life, we hear more 3D by differentiating between arrival time, loudness, frequency, and other things in context of the sound wave. So what you can do is called dummy head recording. And here you can see actually such a dummy head with nearly human ears. And it really catches the sound wave like you would catch it with your ears. And conventional stereo recordings do not factor the natural ear spacing and head shadows and things like that. So if you haven't already tried binaural audio, I really encourage you to give it a try. There are several sources on the web available. One is this autonomous sensory meridian response, where people talk very slow and softly and things like that. But another cool example is the virtual barber shop, and that's pretty awesome. So you got to try this one. And there are a lot of other weird stuff where people are touching, scratching, and cutting around with pretty much everything. But just think of a 360-degree video or VR scene when you have a binaural audio experience as well. I think this will kick the immersive experience and bring it on a whole new level. Another thing you can do is called the sound field recording, where you have a microphone array composed of many professional quality microphones positioned on the surface of a sphere. And the output of the individual microphones are combined and used for digital signal processing, and then they capture the entire sound field. And by some fancy calculations, you can calculate more or less every point in the area of the sound field and provide a really good sound experience. But how does that help us on the web? And this is the time where the Web Audio API comes into the game, which is also a W3C working draft right now. And the Web Audio API is a high-level JavaScript API for processing and synthesizing audio in web applications. So audio is always fairly preemptive. I mean, there was a great step with HTML5 to provide some basic streaming with audio and playback, but it's not too powerful, and it's not powerful enough to handle more complex audio applications and sophisticated web games, for instance. A very active player in the Web Audio API stuff is the BBC. They provide the iPlayer, and they also provide horror recordings with 3D audio recording. And that's also awesome, and you should give it a try as well. So I think there's a lot coming up also in context of audio, which will boost the whole VR and 360-degree video stuff. And I promised to talk about bandwidth a little and how we can make it more efficient to not get our entire video frame. So adaptive streaming is already a big step. I saw lots of use cases where they deal with progressive download with 20 Mbits, and if you have a very good internet connection, you can have the experience, and if you don't, you're not so lucky and experience buffering. So one of the obvious solutions is to use a more efficient codec like HAVC or VP9. And we also did a showcase for HAVC streaming on Android with a modified version of ExoPlayer at the NAB. But to be honest, I don't think that this is good to go right now, because you really have to deal with poor browser support. Another thing is VP9, which makes it a little bit better. And if you have a big audience, I think it's good to go to encode in VP9 because you reach, I don't know, 60%, and then it makes definitely sense to go for another encoding in parallel. Yeah. Anyway, that's not the only thing what we can do. So here again, only the small part of the entire 360-degree video, which gets downloaded in the same quality as the viewport, is seen. And as said, that's a huge waste of bandwidth. So the natural thing we can do, we can just download and stream the viewport at all. So that's quite efficient, I guess, and not that bad. But actually, the user might look to the left or might look to the right or even up and down, and then the quality of experience is decreasing a little because he or she will see black, and then it's far too late to download missing parts. So we came up with a solution where you download the current viewport in a very high quality, in the highest quality possible, and everything else in a lower quality. Or yeah, you can even introduce a third or fourth level of quality. So you say, okay, I'm going for the viewport with a very high quality, and it's likely that the user will slightly watch left or right, and then I provide him with some intermediate quality and keep the low quality on the outside. And
so you guys do this step?
We are currently working on the solution. We have not deployed it yet, to be honest. But that's definitely something we have to come up with because, yeah, the waste of bandwidth is pretty huge for the other approach. What's also not really good is that we use equirectangular video. So there are other approaches, but the equirectangular video approach is a very easy approach. And on the other side, if you just stitch together a video, it looks like that. So most of the content we are facing is equirectangular video right now. What else can we do? We can, of course, use scalable video codecs, give it another try. Or another thing would be object-based video. But I also talked to a guy from a university in Brussels, and for let's say 20-second video, it took him about 2 days to just cut it out the right way. So I don't see this happening. Anyway, there are a lot of improvement possibilities and a lot of things to do. And to conclude my talk, we just briefly mentioned what we see, what's going to happen next, and that's definitely something about reporting and analytics. So right now, we cannot really provide the content provider with the information where the user is actually looking at the video. So that's something very important for the content providers to see, okay, yeah, most of the users watch in this direction or the other one. Also, user interaction might be a hot topic in the future. We already have requests for eye tracking and things like that. So that could be interesting. And points of interest, of course, so to navigate the user to a special viewport if the director wants it. I already talked about DRM integration, and that we will try to come up with an approach which is feasible and which offers the DRM integration also for VR and 360-degree videos. Immersive audio, that's definitely something we can solve in a narrow time frame because the web API is already available. So we're planning to pass the segments to the web audio API and do the rendering there. And the last thing is the region-based streaming, so that we download the quality, only the highest quality for the viewport, and go for lower or intermediate quality around it. So that's more or less it from my side. Hope you have a brief introduction, or you got a brief introduction to VR and web-based adaptive streaming, the way we see it. And if you have any questions, I'm happy to answer.